Today we're covering lesson 5.4 on sum and difference formulas. These formulas are, a lot of them are going to be on the formula sheet. So today we're going to focus on the first one on there. This is one on the top left. It doesn't hurt to look at it so that you can be familiar with it. But notice we've got a little bit of a pattern here. Won't focus too much on the patterns we have here, but sine keeps the same SIGN sign, plus U plus V gives us a plus in between, minus gives us a minus in between, whereas cosine, we have the same parts, cosine, cosine, sine, and sine, but our plus sign is going to flip to a minus, and our minus sign is going to flip to a plus. Now, application of these are going to be, now we can find, using our unit circle, we can find more values such as, 12ths. We may possibly be able to get into the eighths, things like that. So, starting out here, we got sine of 11 pi 12. And what we're going to do is try to find out how can we write 11 pi 12 as two different values, right? So we can use sine of x plus y, right? So we'll need some amount of 12 plus another amount of 12. And now writing down quick here, right, what are fourths? Fourths would give us, 3 12ths per se. 6 would give us 2 12ths. And what else we have? Thirds would give us 4 12ths, right? So how can we manipulate and get 11? We can do possibly even half, right? A half would be 6 12ths. We can get 11 by doing kind of a 9 and 2, right? So 3 of these plus 1 of these. So we could do 3 pi 4th plus 1 pi 6th to give us 9 12ths plus 9 plus 2, giving us 11 12ths. And so now when I do sine of these, right, you're just kind of splitting up the 11 pi 12ths into two pieces on our unit circle. And now we're just going straight to that formula sheet, right? Reminder, sine of u plus v, I wrote x and y, usually we use u and v, is going to give us sine u cosine of v, same sign, plus cosine u sine of v. Right, so now filling that in, we've got sine of 3 pi 4th, cosine of pi 6th, plus cosine of 3 pi 4th, sine of pi 6th. Now it helps to know your point. So 3 pi 4th radian is going to give us the point negative root 2 over 2, positive root 2 over 2, because negative x, positive y. 1/6 is going to give us root 3 over 2, and 1/2. And remember that these are our cosine values, these are our sine values. So with that information, now I can fill it in, right? Because this is going to go here, this one here, this root 3 over 2 going there, and maybe we'll do a box here for the pi 6, right? So now we're just filling those values in the spot, and then we're going to add them together. So we've got root 2 over 2 times, this is root 3 over 2, plus negative root 2 over 2 times half. Multiplying, I get root 6 over 4, and then we get plus a negative root 2 over 4. They both have 4, so we can just rewrite this as root 6 minus root 2 all over 4. Now, hopefully that gives you a little bit of a sheds a light on why we don't generally have these on our unit circle, right? Not the nicest values in terms of roots. One more, we got cosine of 7 pi 12. So we can do this, again, just a note, you can do it two different ways. We can do a u plus v, where we're going to do, again, possibly 9 12 minus 2 12, which this would be 3 4ths again, and 1/6 again, but using the minus, pardon me. Or we could do, say, a 3 pi 4th plus 3 12 plus 4 12, which in turn is really, this is pi thirds and, sorry, I wrote backwards, this is pi fourth and pi third. right? So we have a couple options. We can do this way, cosine of these, or we could do the minus, but do the 3 pi fourth and 1/6. Both will get you the same answer, and we'll just flip it. So we'll do the one on the left. We'll do a cosine plus, because we haven't done a cosine yet. And so this one is going to equal cosine, both cosines at the start, right? Cosine pi fourth, cosine pi third, and then the sine plus or minus flips. And now we have the sine, sin, after. So sine of pi fourth, sine of pi third. Okay. Now plugging in our value, again, pi fourth is where they're both root 2 over 2. And pi third is 1/2 root 3 over 2. Right? Part of knowing your unit circles, knowing your 30, 60, 90, it helps to know those very, very well. Plugging it in. Here's what we got. And again, reminder, cosine value, sine value for x and y, cosine, sine. So that's where those went. Root 2 times 1 is root 2. Root 2 times root 3 is root 6. And then we get root 2 minus root 6 over 4. Now, the only difference between this one answer and this is this answer most likely would have given us minus root 6 plus root 2 over 4. It would have just flipped it, right? They're still the same thing. It would have just flipped the order. So just a little note on that. That's the only difference between those two. Next, simplify. We got cosine arctangent of 1 plus cosine inverse of x. So first, just write out the whole problem, right? Still treat this as cosine of u plus v. We've got cosine, so this is going to equal, right? Reminder, cos u, cos v, negative sign, sine u, sine v. Okay. Now, even though it's, I'm going to rewrite this as tan inverse, by the way. We're going to use this, and we're going to find not an exact answer per se, but it's going to involve x's and using triangles to solve. So, rewriting it, right, from this form, cosine of tan inverse of 1 times cosine of v. So cosine of v would be cosine of cosine inverse of x minus sine of tan inverse of 1 times sine of cosine inverse of x. Now, this looks horrible, but it really simplifies nicely. Here's what's going to happen. We need a tan inverse triangle and a cosine inverse triangle, and we'll be able to find sine or cosine of those triangles. So tan inverse 1 means opposite over adjacent are the same. So doing a triangle here. Here's my tan inverse. We've got tan inverse means that equals that angle where opposite is 1, adjacent is 1. Solving for the hypotenuse, 1 squared plus 1 squared gives us 2 is c squared. So hypotenuse is square root of 2. There's that triangle. I can now find cosine of tan inverse. Again, this is the tan inverse triangle. So now I can find cosine. Cosine of that would be adjacent over hypotenuse, 1 over square root of 2. I could also find sine, 1 over square root of 2, doing opposite. Now we need one more triangle for the right side, right? Triangle for cosine inverse of x. So this is my cosine inverse x triangle. Remember, cosine is adjacent over hypotenuse. So my adjacent over hypotenuse is going to be x over 1. Adjacent is x, hypotenuse is 1. And lastly, solving for the missing side, 1 squared equals x squared plus b squared. 1 minus x squared is b squared, and then square root both sides. So this is square root of 1 minus x squared. A lot of work, but now with that information, we can fill in and finish here, right? Because remember, this just stands for a triangle. This stands for an angle and a triangle. And so once we finish, we're bringing this back. So what's cosine of the tangent triangle? We have 1 over root 2. 1 over square root of 2. And that is that value. Next, what's cosine of the cosine inverse triangle? Well, that's adjacent over hypotenuse, which gives us x over 1. So that came right down here. And now to the next thing, minus. And now we're doing sine of the tangent inverse. Sine is opposite over hypotenuse. So we get, again, 1 over root 2. We'll rationalize in the end. And then sine of this cosine triangle, we get 1 square root of 1 minus x squared over 1. And simplifying, we get x over root 2 minus square root of 1 minus x squared over root 2. Rationalizing, so we're just going to multiply all these by root 2 over root 2 to get root 2 times x minus square root 1 and minus x squared all over 2. Kind of an ugly looking final answer, but that's what it is. Okay. So we had to rationalize the over square root 2. Next, similar situation, but they're giving us actual nice triangles here. Find the exact value of the trig function given that sine of u is 4/5 in quadrant 1, and cosine of b is negative 12/13 where we're in quadrant 2. Okay, find sine of u plus b and cosine of u plus b. Right? So we're going to find these triangles and use them on both slides. So first, making triangle u. Okay. U has an opposite over hypotenuse of 4/5. So opposite is 4, hypotenuse is 5. 3 squared plus 4 squared plus 5 squared. That's where the 3 comes from. So 3, 4, 5, right triangle. So that's triangle U. Because we're using angle. Next one, now the triangle with V in it is going to give us cosine of V. And again, it's just quadrant 2. So I know my cosine is negative. As they give it to me, my x value is negative, y value is positive. So my sine will be positive. So we've got negative 12 here. 13 is the hypotenuse for, again, adjacent over hypotenuse. Solving, and this is also a Pythagorean triple, we get 5. So 12, 5, 3, 13. Pardon me. 5, 12, 13. And now we just need to write what is sine of u plus v. Sine u cosine v. Keep the same sign plus cosine of u sine v. And again, as you use your formula sheet, you'll get more comfortable with some of these than others. And so now I'm just filling it in. What's sine of u? 4 over 5. We can use this value again, but you can use the triangles too. So this is 4/5. What is cosine of v? That was given to us. That's just negative 12/13 adjacent over hypotenuse. Plus cosine of u. So now I'm doing cosine of this triangle here. Adjacent 3, hypotenuse 5, times sine v. That is going to be opposite is 5. Hypotenuse is 13. Now, we've got 5, 13, 5, and 13. Do not cancel these 5s here because we'll need them. So we get negative 48 65th on the left. 3 times 5 is 15 on the right. And then add them together and we get negative 33 65th. Now, using these same triangles, I'm going to copy paste them here quick. Into the next slide because we'll need them again. And now we got what is cosine of u plus v with the same information. So reminder, cosine of u plus v is cosine u cosine v minus sine u sine v. You've got your formula sheet for this. So use your formula sheet. And now we're just filling in the values. We found all these values last slide. You can go back and fill them in. And so here's what I'm going to do that here. So I'm going to go 12/13. This one was 3/5 minus sine of u was 4/5. Sine of v was 5/13. And we're doing the math. We got negative 36 65th minus 20 65th, giving us negative 56 65th. Moving on, verifying the identity. So go ahead and use the cosine u minus v rule and see if you can verify to get sine of x on this one. Pause it and try it yourself. And here is the work. Cosine of pi half minus x. Using u minus v, we get cosine u cosine v plus sine u sine v. Well, filling in. What is pi half then? Pi half is a 0.01, so these are my cosine, these are my sines, filling it in. 0 times cosine is 0, 1 times sine of x is sine of x. 0 plus sine of x is sine of x. It's a pretty short, quick proof. Feel free to pause to write these down. One more, same idea. Tangent. Tangents is a little longer, right? So you definitely want to use your formula sheet for this one. So tangent x plus pi is going to give us tangent x plus tangent pi over 1 minus tangent x tangent pi. Minus, now we're doing the exact same thing, but it's the minus formula. So tan pi minus tan x over 1 plus tan pi tan x. Now, what is pi? Right? Pi is the value where we are -1, 0, and tangent is y over x. Right? So we're going to get 0 over -1, which is 0. So anytime we see tangent of pi, that's what we get, 0. So zeroing out every tangent of pi, so to cross them out. We got 0 here, 0 here, 0 here, and 0 there. So now writing, what's left over? I've got a tangent of x over 1 minus 0 times tan of x, so that's just going to be 1, right? Because these 0 times tangent is 0. Then on the right here, we got minus a negative tangent of x on top over 1 plus 0 times tangent. And so we've now got this double negative going on, so this becomes tangent of x plus tangent of x, which is, I count, 2 tangent of x. So some of these are pretty short. It's all about filling in the formula, figuring out your point, double checking what is tangent of that point, and then plug it in. Solve all solutions in the interval for 0 to 2 pi. Now this kind of comes back to yesterday's lesson of the 5-4 solving equations, but it's still using the u plus v formula. So just writing it in. Sine x cosine of pi thirds plus sine cosine x sine pi thirds. That's the first piece. That was all that piece. Switching colors, doing the next piece. And again, plus sine x cosine pi thirds minus sine cosine x sine pi thirds. And now plugging in, what is pi thirds? Pi thirds is a 60-degree angle. That's going to give us 1/2 root 3 over 2 for cosine and sine respectively. So plugging it in, we've got 1/2 of sine of x. Kind of flip the order here. This one's half. This one's root 3 over 2. And then this one's root 3 over 2 over here. This one's half. So we got half sine of x with the first piece plus square root of 3 over 2 cosine of x plus half sine of x down here minus square root of 3 over 2 cosine of x. Using some blue pen here to cancel. These cancel. And we get half of sine of x plus half of sine of x gives us sine of x. These two add equal sine of x equals 1. Bringing that back in, that's where the equals 1 comes from. So it's like what? Back in from the top. And where does sine of x equal 1 between 0 and 2 pi? Right there. X equals pi half. Right? Because again, this is a y value. So we get that 1, and then everything else is less than that. So our answer is x equals pi half. That's the only solution between 0 and 2 pi. One last question, and this is write the expression as sine, cosine, or tangent of an angle. Okay, so this is saying which pattern does this follow, right? Which one does that look like? Does that look like sine or cosine? And then we're doing the u plus v. Now this is, they match, so it has to be cosine. The signs, SIGN, plus or minus, doesn't match. So this is going to be cosine of u plus v equals cosine u, cosine v, minus sine u, sine v. Right? That's the pattern we have right here. This matches here. So u is 60, v is 10. Plugging it back into cosine of u plus v, we get cosine of 60 plus 10, gives us cosine of 70 degrees. A little bit of a tricky one, but you're working the other way. We're working from the right side of our equation to the left, and that one gave us cosine of 70 degrees. And that wraps up today's lesson. Feel free to ask any questions during our class.